I taught, if you want to find the distance to an object you can't possibly touch, like a star, you have to measure it with what's called parallax trigonometry. You have to know two sides and one angle, or two angles and one side, in order to calculate the distance to this unknown point, or to this unknown distance to this point, with simple sine, cosine, tangent. The problem is, Earth is only 8,000 miles in diameter, which is basically nothing compared to star distance. So to find the distance to a star, you have to get your observers further apart to make a triangle. That's, a decent angle. Well, they look at the star in January, then they look at the star in June, and they get a much bigger base on their triangle. This is Earth's orbit around the Sun. Well, it's 93 million miles to the Sun, which is a long ways, but it takes light 8 minutes to get here from the Sun. It's called 1 astronomical unit. That is, the distance from the Sun to the Earth is an AU, an astronomical unit. So we are 8 light minutes from the Sun, which means the diameter of our orbit is 16 light minutes. That would be the diameter of Earth's orbit around the Sun. This diagram here shows a little yellow dot on the far left. That would represent Earth's orbit, 16 light minutes. A year has 525,000 minutes in it. That's a real skinny triangle if you did it to scale. It's like having two surveyors with telescopes 16 inches apart, looking at a dot 525,000 inches away, which is 8 1/3 miles. You set that up and draw it out on a piece of graph paper, you find you got a real skinny triangle. It works out to be an angle of 0.017 degrees at the apex. I think you can have a hard time measuring something like that. If you want to measure 100 light years, by the way, that was just to measure 1 light year. If you wanted to measure 100 light years, you'd have to move your dot 830 miles away, keeping your surveyors 16 inches apart. That's like having two guys on my roof here in Pensacola, Florida, looking at a dot in Chicago. If the guys are 16 inches apart and they're focusing on a dot in Chicago, that's a real skinny triangle, okay? Figuring 15 billion light years is clearly impossible. It just can't be done. And I don't think you can tell exactly where you were 6 months ago on opposite sides of Earth's orbit. That would be a stretch also. Okay, this textbook says parallax trigonometry can be used to measure distances less than 100 light years. I agree, much less. I think you'd have a hard time measuring 20 light years, but I'll give them 100, I'll give them 500 for the sake of the argument. The fact is you can't measure a billion. I'm not saying the stars aren't that far away, they probably are. I'm just pointing out we have no way of measuring it. We don't know how far away they are. If somebody tells you that star is, 7.9 billion light years away, just say, how did you measure it? Was it a Stanley, a Lufkin, or a Craftsman? And who held the other end of that tape measure? Because I want to meet this guy. It just can't be done. So number one, we cannot measure the distance to the stars. Number two, we don't know what light is. Is it a wave? Is it a photon? Is it a particle? It behaves sometimes like waves, sometimes like energy. Nobody knows for sure what light is. We know what it does, and we use it all the time, obviously, but nobody's ever defined what light is very clearly. So the entire principle or concept behind a black hole is the idea that light can be attracted by gravity. Well, if light can be attracted by gravity, if black holes exist, which nobody's proven that either, but then the speed of light can't be a constant. At Harvard University in '99, they slowed light down to 38 miles an hour. The next year, they slowed it down to 1 mile an hour in the year 2000. The next year, they brought it to a dead stop. They took light and absolutely stopped it. This was done at Harvard, it was done at Smithsonian, and it was done at Cambridge. And by the way, that's how science works. An experiment should be demonstratable, repeatable, testable. Evolution is none of those. Nobody's ever demonstrated or tested or proven any of it. It's all in the mind. They think it happened. It's not science. Okay. At Princeton University in the year 2000, they speeded light up to 300 times the speed of light. Why would the speed of light be an unbreakable barrier? Barry Setterfield, Australian astronomer, did a lot of work on the speed of light question. He says the speed of light has decreased. He said in the last 300 years, at least 164 measurements of the speed of light have been published, 16 different ways it was measured. He said the speed of light has apparently decreased so rapidly that experimental error cannot explain it. Here's a chart showing that the speed of light has declined in the last 150 years. About 1960, the chart seems to level off, and everybody since about 1960 has gotten the same number. If you measure the speed of light today, you're probably going to get 186,282 point something miles per second. Okay. That could be because in the late 50s and early 60s, they began using the atomic clock to measure the speed of light. And the atomic clock uses the wavelength of a cesium-133 atom, which means you're using light to measure light. You have a rubber ruler. Of course, you're not going to see it if it's declining. It may be we're on the tail end of a logarithmic digression, or it simply may be we're using a rubber ruler by using an atomic clock to measure it. Here's a couple articles showing about how that the speed of light was apparently exceeded by a factor of as much as 100. Clear back in 88 and 95, there were articles published about this. The speed of light is not a constant. The Radiophysical Research Institute in Russia, the cosmologist there, said the speed of light was 10 billion times faster at time zero. Astrophysics and Space Science magazine, 1987. According to the Big Bang Theory, the speed of light had to be much faster initially. Here's an article from 2001, Science News, saying about the speed of light may have changed over history, study says. Imperial College in London, the man wrote an article and said a shocking possibility is that the speed of light might change in time during the life of the universe. At Rutgers News Service put out an article from Sydney about a team from Australia that said the speed of light may not be a constant in August of 2002. It says the speed of light can change. The speed limit of the cosmos is being questioned. September 2002. So, there's a book out called Faster Than the Speed of Light, and I'm sure this fellow who wrote this book will be persecuted for daring to suggest such heresy as this. Discover magazine ran an article about this. Was Einstein wrong about the speed of light? A recent article saying Einstein was wrong. The speed of light is not a constant. So, I don't think we can prove what light is, and I don't think we can prove light's always traveled the same speed. Number 3.